Hey, how's it going, guys? So here we are for another devlog on our weekend project for OpenFDD. We're on version 2.0.3 and we have a new user interface all written in React. So at the moment we have an API and we also have a UI. So we're collecting data in a timescale database. There's an optional Grafana way to spin up a Grafana, and there's also predefined Grafana queries in the online documentation. But for now, this is built into OpenFDD. New user interface showing that the API is online. There's backnet, it's scraping. This is some MQT thing for the future. We have a data model with 3 equipments, 35 points, 0 active faults. Our AFDD routine ran 3 minutes ago, and we're still fetching data from openmedio.com that also runs the same time as our AFDD routine. So through the UI, you can set up the configuration for OpenFDD. So like I was saying, FDD is set up by default. It runs every 3 hours, look back over 3 days in case you want to tune rules, and then see how your rules panned out in historical data. We also have backnet scraping with our backnet server on our local host on our gateway. OpenMedio is set up to scrape data from Chicago with our site ID as just my test bench at the moment. So like I was saying, like automated fault detection can be ran on any interval. I'm just defaulting to 3 hours and a look back of 3 days just for the rule tuning purposes. And you can also view the raw data model, RDF data model, in a directory on the computer. Some backnet gateway setup, OpenMedio in case you want to change it. So at the moment I just have 2 devices on a test bench actually. So this is all ran from a backnet discovery. So the application OpenMedio supports doing backnet whois, and then there's also a point discovery. So you add your data to the data model through the UI, kind of like a building automation system. You can add in points and we'll start scraping data. At the moment I only have 2 sensors tagged in the brick ontology, so that's why you only see a couple point values here, because this is the only thing that I've tagged. But it's showing that we just scraped fresh values just a couple minutes ago. OpenMedio, so like I was saying, this runs every same time we fetch data from OpenMedio. It's a weather service API, it's free. You can get a lot of cool historical weather data, which I think can be kind of important for analyzing performance for HVAC systems, which are very weather dependent. This is our VAV box, and I have 1 point defined in here, which was scraped just now. Okay, so data modeling processes, this was the same as we did before. So like we can actually, our data model, we can serialize it to turtle format here, check the integrity. We can also view the data model, and this will pop open a new browser tab. And then this is basically the data model. Here in brick ontology, it's tagged with some AI assistance here, which I'll have to demonstrate, I think, on a future video. But basically, it's the same process that I've did before. Is you can export something that AI can understand. It's JSON. It's basically this in a JSON format, where then AI can then, you just download JSON from the server. Kind of looks like this. So I'm using ChatGPT, but ChatGPT has a predefined prompt in the main README for OpenFDD, which I might as well bring up here. So this is our predefined prompt, which you can copy right into, hit the copy button, dump it right into your large language model, along with the JSON file that was extracted. And ChatGPT is instructed to assist in tagging, and then also set polling equals true or false in our data model, so which is defines on the back end if we're going to start scraping that data via backnet. And we're also set units too, so that's something for plotting. So we asked the large language model to set some breakpoints, polling in units for whatever we want to start running fault detection on. This is also kind of just exploratory at the moment, but it's kind of cool to have AI-assisted data modeling efforts. So I'm definitely looking for people to try this, test it out. And there might be some ways we can improve this. All right, so this gives you some abilities to just see what's going on. Weather equipment is tagged, that's brick. Weather service for open media. And you can also run Sparkle queries, so you can type in any kind of a query that you want, which I think is really important to get into a little bit later in time. Also, the online documentation, this still needs to get cleaned up. It's kind of a little bit messy at the moment, but there should be some how-to guides on. Let me see. So where are we? So we have to get into data modeling, and then there is a Sparkle query cookbook here, so we can find this is basically how this might need a little bit of update. So we could find backnet device and object. So this is basically for testing purposes, so you should be able to run this, run a Sparkle query. Okay, so it's a few things that we're still clearing up here. So we'll be able to basically have a Sparkle query cookbook, and then run Sparkle queries through the browser against our data model, and then retrieve useful information about our backnet devices. I'll have to clean this up. So I think we would be, let's try this once. Equipment, this is part of our brick tag. Anyways, I'll probably do a whole separate video once I clean up the documentation on how to use the Sparkle query cookbooks, but you'll be able to run Sparkle queries against your data model. You'll also be able to delete things out of your data model, add new sites or devices. So what happens behind the scene is the API keeps in memory an RDF graph representation of your data model, and you can add things, delete things, discover things via backnet right into your data model. So more to come on that. I'll probably do a whole separate YouTube on this alone, of just this feature of data modeling within OpenFDD. This is something too for fault detection, getting into a little more sophisticated things. So I am just testing. There's two fault rules that I have here for. You can see your fault rules here. This is just a sensor bound. So sensors that have on my test bench here in imperial units, I have a fault rule running that they must maintain this basically a bounds. If the sensor goes out of that range, it's a fault. We can see we flag some faults here. And also I have a flatline sensor. So these fault rules also run against the data model for time series references. So that's why you see this will run against supplier temperature sensors as defined in the data model. So we're not running fault rules against raw messy point values or database references. It's all data model based. If we get into the plotting section here, let's go back on the past 24 hours. We can select some sensor values, and you can see right here, this is just fake data. So it's meant to produce faults for testing purposes. And you'll be able to set, bring up a plot here for your bad sensor flags. Still a few things need to get cleaned up, but this will be the look and feel of being able to view your fault detection data and your sensors, and even OpenFDD data too. So there might be more data than what here, but you'll be able to view data from the web, from weather data against your HVAC data, and even in the this still needs to get cleaned up too, but we'll have an expression rule cookbook basically. So you'll be able to have basically a whole cookbook of expressions to run whatever you want, all based on data modeling. And then this is your fault rule right here, all defined in YAML files. This is also something I'm trying to do is hot reload, so you can tune parameters here for your fault detection parameters, and then just watch it on the live system for everything to update. Weather data from OpenFDD, you'll be able to see this. It also scrapes some solar radiation data, wind speed, outdoor temperature, relative humidity, dew point, cloud cover. So basically anything, if someone wants to model something, you'll be able to do that. Also, a feature in here is, let me show you this real quick, but you'll also be able to select here and then download a CSV file, basically export a CSV file of your data. And this is also getting into the diagnostics, the fault detection. This will be a later feature. I think once everything is cleaned up here and working well, we'll get into analytics and also the fault detection and diagnostics, which is also some cool feature of the data modeling process to help us see all of the rules and relationships of HVAC systems, how they operate inside buildings. There's also a systems resources here too, so you can see basically the performance of your computer, how much memory each one of your Docker containers is consuming, and also how much space you have available. I just have like an old server here running that's also a repurposed computer on my test bench, so it doesn't have a lot of memory or anything or storage space, but it's mostly just for my test bench purposes. So this is all I have for today, guys, but it's getting there. We're getting to to have something useful and free, and I think in the future we'll be adding in my next update here. It will be adding in some more security to this application. So at the moment, we're using Caddy right now just as a reverse proxy to kind of protect our API, even though we're operating behind the firewall. The next couple updates will be more security in logging, or adding in a login feature for your OpenFDD user to maintain your maintainer, and also some secure coding practices. So that's coming. So hopefully you're enjoying watching this come along. Look for updates in here too, because this needs to get cleaned up. But we're actively looking for, I'm actually looking for people interested in wanting to try this out. So it would be more of an advanced power user someone that would be have like a backnet network available for testing purposes, which some researchers might have at some universities. And it'd also be someone at the moment comfortable with like bootstrapping Docker, Linux commands. Basically, it takes about the same effort as to bootstrapping like a web app, for example. So people that would be comfortable doing that. So looking for some testers, early testers right now, just to support some bug findings, and practice some data modeling in our AI assisted data modeling efforts. And this will come, the more that we test this, the more better this app will be. So it's getting there week by week. Thanks for following along, and talk to you guys next Sunday for our next dev check-in. Have a good one.